Today we are going to look at different bisectors and lines that go through triangles. So first, a vocabulary word, equidistant. Equidistant is just what it sounds like. It's a point that is the same distance away from something else. Remember that perpendicular means two lines that intersect and they form right angles. So we have line X and segment XY intersecting and forming a right angle. They're perpendicular. So if a point is on that perpendicular bisector for your segment, then it is equidistant from the endpoint. So line XY is a perpendicular bisector of segment AB, so it's perpendicular to segment AB, and it is cutting it in half. When that happens, you know that this last side of this triangle, AX and BX, are equal to each other. You know that the converse of this is true as well. So if you have a point on a line and it is equidistant from two endpoints of a segment, then you know that that line is a perpendicular bisector for the segment. And so that means that line XY is perpendicular to segment AB, and that line XY is cutting line AB in half, or segment AB in half, meaning that segment AY is congruent to segment BY. On our first example, we have a perpendicular bisector. Line L is a perpendicular bisector of segment PQ. Because we have that, we know that segment PR is congruent to segment QR, which means that we can set these equal to each other. So 2n plus 9 equals 7n minus 18. And then we're going to solve for n. Subtract 2n from both sides. That gives us 9 equals 5n minus 18. Then we're going to add 18 to both sides. And 27 equals 5n. Then we're going to divide by 5 on both sides. And n equals 27 fifths. Now, for those of you who like changing your improper fractions to decimals, today I highly recommend that you do not do that, because there will be a problem on the assignment that you get incorrect because you rounded inappropriately. So please leave your improper fractions as fractions. Then we need to find the length of PR. So we need to substitute. So we have 2 times 27 fifths plus 9. And that gives us 5 99/5. Next up, we have angle bisectors. So this time, instead of bisecting a segment, we are bisecting an angle. We're cutting an angle in half. So when we have a point on an angle bisector, so ray PC is an angle bisector because it's cutting angle APB in half. When you have a point on your angle bisector and it is equidistant from the sides of your larger angle, or when you have a point on that it's equidistant from the sides of your angle. So that means that the length of AC and BC are equal, they're congruent. We also know the converse of that is true as well. So if you have a point in the interior of an angle and it is equidistant from the sides of your angle, so if you know that point C is the same distance to point A as it is to point B, then you know that point C is on an angle bisector. Making ray PC again an angle bisector. Which means that angle APC is congruent to angle BPC. The two smaller angles would be congruent because of this. So in our next picture, we know we have an angle bisector because we have arc marks down here showing us that these angles are congruent. And because of that, what is the length of LM? It is 12.8. Next up, medians are another kind of line that go through a triangle. Now a median has to go to the vertex and it has to go to the midpoint of the opposite side, meaning that it's cutting that side in half. So those two things have to happen for a median. Then you have an altitude. An altitude, again, has to go through the vertex, and it goes to your opposite side and makes a right angle. Now, in our next figure, we have an isosceles triangle. So remember that an isosceles triangle has two legs that are congruent, and we want to sketch in the angle bisector of the vertex angle. Remember that this top angle is the vertex angle. And if we draw in the angle bisector, that means that these two angles are congruent. Remember when we talked about congruent triangles, that the line that they share, because now we have two smaller triangles here, the line they share is congruent to itself. So we have side angle side here, which means that we know that the base is getting cut in half, which makes that angle bisector a median. So we have a median. We also know that these angles are congruent and that this angle is a right angle, which means we have an altitude because that's a right angle, and we have a perpendicular bisector. So when you have an angle bisector in a isosceles triangle, the angle bisector is the median, the altitude, and the perpendicular bisector. Okay, so in our next figure, we have a angle bisector, and this is an isosceles triangle. We know our base, so how would we find x? We would divide 22 in half, and that would get us 11 for x.